A3.6 and A3.7, I'm going to just do on this one slide. So A3.6 would like you to label the parts of the ear. But I'm just going to go through and just talk real quick about how sound is perceived in our brain as we travel through and we start labeling it. So the outer part of your ear, this gigantic satellite, some people have bigger satellites than others. Barack Obama had very large ears. This thing is called the pinna, and this basically catches the sound waves. The sound waves come in actually as pressure waves. So as they're working their way through the ear canal or the auditory canal, same thing, they come down and they hit this thing called the eardrum. The eardrum is also called the tympanic membrane. T-I-M, tympanic. So the reason that eardrum is there, or the tympanic membrane is there, is that the pressure or those sound waves that come through the ear canal aren't really strong enough to do what you're going to need to do down here. So it needs to be amplified. And the way it's amplified is with these three bones. So this eardrum vibrates because of these sound waves, causing these bones, boom, 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 the malleus, the incus, and the stapes, they begin to vibrate. And when they vibrate, this last one, the stapes, is banging against this other membrane, which is kind of hard to see, called the oval window. And the oval window will send vibrations that are 20 times stronger than if there was no eardrum and no bones. So all of these structures here are meant to amplify the sound 20 times. Inside here is liquid. So this is called the cochlea. And inside of here, there are tiny little there's tiny little cilia, which are like hair-like structures on top of nerves. So when those little hairs move, because we're creating waves inside of this cochlea, and the waves will cause the hairs to vibrate, sending a signal to that nerve, and that nerve in turn will send a signal here to the auditory nerve, and then that goes to the noodle up in your brain. It goes up into your brain, and then you can perceive sound. And depending on the pitch, depending on the frequency of the sound, will determine which hairs get vibrated. So we'll talk about those in more detail. Just some other structures here that I didn't mention. The round window is also part of the hearing, so it kind of dampens the vibration. So as the oval window here is vibrating, the round window absorbs those vibrations. Down here we have the eustachian tube, not related to sound. Basically, it's just a way to pressurize your eardrum. So you have your nose down here and your throat and everything, and you can pressurize. I'm sure you've done this if you've ever been on an airplane, by swallowing or maybe holding your nose closed and blowing, and that will pressurize this so you don't damage your eardrums. Anybody that's been deep sea diving or snorkeling also knows this trick about pressurizing your ears. And the last little thing up here is called the semicircular canals, and these are involved with balance.